Welcome to the Fast Track RFID Certification Review. We will discuss the RFID architecture. What are the components of RFID systems? There is an RFID reader, one or more reader antennas, a cable that connects the reader antennas to the reader, RFID tags that are placed on or inside an object, and a software application that is used to transfer data from the reader to the backend system that also processes the data and filters and aggregates the data. This is called RFID Middleware. There are various kinds of RFID readers, and we will discuss them more in detail. But first, what do the RFID readers do? They perform air interface functions. They read data from the RFID tags, and they also write data to the RFID tags. This is all using an RFID antenna. Readers also perform anti-collision and filtering, and they work with one tag at a time. But this procedure is done very quickly, and readers can handle tag populations up to thousands of tags in a few seconds. Readers also perform reader management functions, and they communicate over the network with host computers. Readers usually support multiple protocols such as EPC Global and ISO protocols. They can run various GPIO devices, which means general purpose input-output devices, which include light controls, motion sensors, electric eyes, horns, and other input-output devices. Readers come in various form factors, such as fixed and handheld readers that we will discuss more in detail later, and they can have multiple antenna ports. There are readers that have one antenna port or up to 16 ports. As I said earlier, we have several types of readers. We have handheld readers, mobile readers, or fixed readers. Handheld readers have usually a self-contained form factor. They include also an antenna, also the reader, and also display and keyboard. And they're mobile. You can carry them anywhere. And then there are fixed readers that are usually mounted in portals or in certain fixed location. Readers can be single protocol or multi-protocol. Today, UHF readers usually support multiple protocols such as EPC and ISO protocols, but there are some that support only one. Readers usually support only one frequency band, which is either UHF, HF, or LF. And of course, the reader and tag frequencies must match. Readers can be bistatic or monostatic. Bistatic readers have antennas that have separate functions. One antenna port has a transmitting function, and second antenna port has receiving function. That means that you need always two antennas in order to be able to communicate with tags. Then there are readers that are monostatic, where the antenna ports have a double function. They both have transmitting and receiving function. That means if you connect only one antenna, you will be able to talk to the tags. There are also readers that have integrated antennas. This is very convenient, especially for installation in small spaces where we have reader and integrated antenna right inside, and you have only one thing to install. Sometimes integrated antenna readers have also external ports so that you can add additional antennas to extend your read zone or make a little bit different shape for the read zone. There are external antennas also where they can be single or multiple. As I said before, we can have 1 to up to 16 ports, and if we need even more ports, we can use hub or multiplexer. There are various ways you can power RFID readers. You can use battery, AC power, or Ethernet. Power over Ethernet is becoming very popular with fixed readers because you can have only one connection, only one wire coming from the reader, which supports communication as well as power. Readers can be dumb or smart. Smart readers perform various functions, including anti-collision, filtering, logic, and they can make sense of the read events. Dumb readers only pass data to the backend application. There are also various network connections that you can encounter. They can be serial, such as RS-232, or Ethernet with RJ45, or you can also have wireless connections, such as Wi-Fi or Bluetooth. Wi-Fi and Bluetooth is usually supported by handheld readers, and serial or Ethernet connection is usually supported by fixed readers. But it's possible that you can find also wireless or Bluetooth capability on fixed readers as well. There are other reader functions that are usually present within the smart readers. Readers have to comply with standards for air interface as well as host interface in order to be able to communicate with tags as well as with the backend systems. A reader has to be able to read any tag within the particular frequency band. Readers are usually made to work in any geography, and the compliance with particular regional standard as far as frequency, duty cycle, and power is achieved by specific configuration of internal radio by reader software. Readers also have to support standard protocols such as TCP/IP, UDP, DHCP, and HTTP. They also should be able to communicate over Ethernet or support wireless LAN. Readers should be able to perform event management functions, device health monitoring. They should be able to be configured and upgraded remotely, and they should be based on open standards. They should also support standard host interfaces such as UBC Serial Protocol, ASCII, XML, or various user-defined formats. Readers also usually have data management features such as they are programmable and they can program tags. They perform reader filtering. They provide event generation, filtering, and buffering, and also support queries. This is all to manage tag population. Let's review UHF fixed readers. Here are various types of fixed readers from different manufacturers. From the top, it is CSL, Impinj, and Alien. From the bottom is Zebra, Intermec, and ThinkMagic. They all look very similar. They all have antenna ports, network connections, and power connections. We'll look a little bit closer on the Zebra FX9500 reader. If you look at the reader from the bottom, you can see that it has 8 antenna ports. They can function as 8 monostatic ports that perform transmitting and receiving, or as 4 bistatic ports that each have dedicated function. Then we have a GPIO connection, Ethernet and USB connection, and also RS-232. On the right hand side, there is a power connection. Here you can see the diagram for the FX9500 connections. As you can see, you can connect up to 8 antennas. Reader antenna ports may be susceptible to damage from static discharge or other high voltage. So usually you have to make sure that you use proper ESD precautions to avoid the static discharge. This is especially in environments where the ESD is present. If you don't, it's possible that you can damage the antenna or even the reader. Also, good practice is to connect the antennas and the power supply first before you connect the power supply to the power. So first connect antennas and then power the reader. This is all to avoid damage. Let's look at the handheld readers. So here are some good examples of handheld readers, and we have various types of handheld readers. There could be full-blown computers, such as the one on the right. This is the Motorola, which includes a display, includes a keyboard, reader antenna, and a trigger. Or we can also have a sled handheld reader, which is basically just a handle with an antenna, and then you can connect your smartphone into this, and smartphone is what runs the whole device. Let's look at the Zebra MC3190-Z or the MC3190-Z. They're similar. They're both full-blown RFID computers, and they have the reader antenna up front. On top, there's a display and a keypad. Then you have a handle that holds the stylus, and and there is a battery on the bottom of the reader. Usually these readers communicate over Wi-Fi, or they can also sometimes do Bluetooth. Now we're moving to RFID antennas. RFID antennas can come in various shapes and sizes. If you just out of curiosity, here on the right hand side at the bottom, this is actually a mat antenna. So you can place it on the floor and then drive across it and it will read your tags. The one on the left with the big sign impinged, this is a threshold antenna, which has similar function as the mat antenna. Also, you can place it on a threshold or embed in the floor, and as you drive over it, it will register the tags. The antennas on top are standard patch antennas that are used in portals. So what does the reader antenna do? It transmits the reader's interrogation signal. It receives the return signal from the tags. It comes in various shapes and sizes, and usually the size depends on the frequency. So as the frequency increases, the wavelength, and therefore the antenna size, decreases. As you can see, usually low frequencies have much bigger antennas, and the other way around. Also, the size of the antenna affects the read range. Antennas can be circularly or linearly polarized. Here are some good examples of RFID antennas. As you can probably recognize, the second one would be theft prevention antenna in the store, and that's usually HF. On the right is the smart pass antenna. Then there would be HF or LF antennas, and at the end is the bistatic UHF antenna. Here are some common types of antennas. So the ones that we use for RFID most often would be the patch antennas. Sometimes there are used dipole antennas. The monopole, loop, slot beam, or Yagi antennas are used very rarely. They're usually used for data transmission, not as much for RFID technology installations. So here is a closer look at the configuration of a patch antenna. This is what you would see if you remove the radome or the cover from the antenna. So this is a patch, that's the radiating part that is attached to a ground plane, and there is a feeder or a cable that goes to the reader. There are key antenna parameters such as directivity, radiation pattern, gain, and polarization. So the antenna directivity is basically the direction the antenna is radiating most. And as you can see, here's the radiation pattern on the bottom right, and it is actually not ideal oval. It radiates mostly into the front, but it also has side lobes and back lobes. Here you can see a simplified antenna pattern, and you would probably think, why does antenna have a back lobe? Well, this is what happens when the signal bends over the ground plane of the antenna, and then it could radiate to the back. When you're looking at antenna specifications, you would look at the front to back ratio, and you would want it to be as large as possible if you want your antenna to radiate mostly to the front rather than to the back. This is all given by the antenna construction. You've probably heard the term antenna gain. Well, the gain is defined as ratio of the signal that's transmitted in the direction of peak radiation to that of reference isotropic antenna. Sometimes it's referred as forward gain, and it's measured in decibels. In general, the higher the gain, the smaller the beam width. It's really easily seen on this little graphic. So the top antenna is a low gain antenna. It has a wider beam width, but shorter read range. The antenna on the bottom has longer read range but narrower beam width. The bottom antenna is a high gain antenna and the top antenna is low gain antenna. Both antennas are useful in RFID installations because sometimes you want your beam width to be wide as the tags are passing through the interrogation zone, and you're not as worried about the distance. For high gain antennas, you want to achieve a far distance, but you want to make sure that your beamwidth is narrower in order not to interfere with possibly other read zones. Then there is polarization. So antennas can be linearly or circularly polarized. Linearly polarized antenna radiates within one plane. So as you can see here, if you had a single dipole tag, that it has to be facing the antenna, and it has to be in the same plane as the radiation in order to be powered and respond to the antenna. The linearly polarized antennas have very focused beams, and they achieve longer read ranges. But they're not very practical if you don't know what your tag orientation is. On the other hand, circularly polarized antennas split their beam into two planes and rotate the radiation, so basically the tag can be in any orientation as long as it's facing the antennas, and it would be read. Circularly polarized antennas have a little bit shorter read range because of splitting the power. Let's discuss another component of RFID systems. Those are RFID tags. You've heard a lot of information and basically introduction of RFID tags in the part 1. So we'll go over some of these things very quickly. As you know, we have tags that are passive, semi-passive, and active. Passive tags do not have battery, and they respond to reader by reflecting the reader power. Active tags have their battery and transmitter, and they do not need the reader in order to communicate. Semi-passive tags work same way as passive, but they have battery that help them with communication in order to power quicker and also to be able to talk further. Then we have tags of various frequencies: low frequency, high frequency, ultra high frequency, microwave frequency, and ultra wideband frequency. The performance of the tags is depending on the frequency, on the environment, on the materials we're tagging, and tag position. So let's review a little bit more what affects the tag performance. Let's look at the environment first. What if you have a lot of metal in your environment? Well, metal is a problem. No tags can read through metal, and metal causes reflections, interference, diminished read range, or reading what's not desired. So how do you solve this? Usually this can be solved by shielding, tuning, and antenna tilt. There are also environments that you can have a lot of water, or you're tagging things that are liquids or moist or have moist materials. So what happens with the tags then? They get detuned, the signal gets absorbed, and there's diminished read range. So here are some what can you do? You have to perhaps read in line of sight. You have to tune the power of the reader, angle the antennas, or perhaps add read points. What if there are other readers in the environment that cause interference, diminished read range, lower data rate, and lower tag reads? Well, this is usually solved by dense reader mode, tuning power, adjusting gain of antennas, tilting the antennas. But dense reader mode usually should be able to take care of it. So what can the tag materials do to the tags that they don't respond or don't get read? So usually the materials can detune the tag. Metals are especially good at this. When a tag is placed on a metal, or standard tag, standard label is placed on the metal, it is detuned to the point that it doesn't respond, and because the metal surface interferes with the tag antenna and also the metal block signal. Aqueous liquids can also detune the tag, as well as the condensation or the moist materials. So what can you do? The best solution is to use tags that are specifically tuned or made for use on metals or moist materials. There are a lot of tag manufacturers or tag converters that take standard tags and then they encapsulate them or place them onto specific materials that prevent the detuning and provide small offset from the surface, and that enables the tags to respond normally and they do not get detuned anymore. Also, what you have to consider is the tag position. The tags have to be placed in a position where they're going to be able to read by the RF signal. So the tag should be as much as possible in line of sight, especially when tagging difficult materials, and it also has to be parallel to the surface of the antenna. And if you have linear antenna, the tag dipole has to be in the same plane. But usually circular antenna is more practical as you don't have to worry about tag orientation. Last but not least component of RFID systems is RFID middleware. What does the RFID middleware do? It manages hardware devices and communicates between readers and business applications. That is why it's called middleware. It sits in the middle between the hardware and the business applications. It transfers, formats, filters, and distributes data between the reader and the system applications. It is actually made up of several elements that include event management, data conversion, database management, data consolidation, data reporting, and so on. Usually middleware does not manage compliance with standards and regulations. This is the job of the reader firmware. Here's a nice graphic that shows you where middleware lies within all the infrastructure of RFID systems. So as you can see, it takes care of device monitoring, data filtering, aggregation, and applying business rules. Then it goes into data translation and local database, and then it transfers the data to the applications and services and event management that then talk to the backend systems such as supply chain management systems or other ERP systems within the company. In this module, we reviewed RFID architecture components. We discussed fixed readers, handheld readers, RFID antennas, RFID tags, and RFID middleware. Stay tuned for Module 3.